Hey class, welcome back. Today we're finally getting into logs. I know this whole chapter is about logs and we've done 3 sections and haven't even seen them yet, but 3.2 is the first time that we see them, and then we'll work with them from here on out. So today we're going to deal with logarithmic functions. We'll convert between log form and exponential form. I'll show you how those are related and how we can solve problems with it. We're going to evaluate some log expressions, and then we'll use the one-to-one property for logs, which is real similar to the one that we learned, the one-to-one property for exponents in one of our previous screencasts. So first, just want to make sure that we realize that logs and exponentials are inverses of each other. So that's why we can use one to solve the other. And this opposite is also true. To do this, we need to be able to convert between log and exponential form. And this is like the most basic way for us to solve problems. So if we don't understand this, then it's going to be quite a challenge. So first, let's take a look at pieces of a log. Anytime I have like log base b of x, maybe we'd have an equation. This part right here is log base b. Okay, so that's how we would say that. Log base b, I should probably keep going there, of x. Log base b of x. Okay, sometimes people just say log b x. That's not really accurate. It's log base b of x. And saying base b, I think, is really important when we start converting to exponential form. So, all right, let's go down here. There's 2 different ways that I've learned to kind of remember how to convert between the 2. I think we all know what an exponential equation looks like. Over here we have our exponential term b to the y, and it's equal to x. So b is the base, y is the exponent, and x over here is the answer. If you switch that around and say x equals b to the y, those parts still all remain true. When you convert to log form, some people remember this word bay. You guys probably know this word more than I do. This wasn't a word back when I was in high school, but B-A-E. Those 3 letters stand for base, answer, and exponent. So we write log base b of x equals y. The base of the exponential term becomes the base of the log. That should be pretty easy. And then the answer goes inside the log, and the exponent goes after the equal sign. So log base b of x equals y. There's your B-A-E, your base, answer, exponent from this form over here. The one that I use, which I think, just because I'm a visual person, you can kind of stack these up. If you start with this that I underlined, log base b of x equals y, we can use the drop and swap method. Just remember that your log is on the left side, and see how the log base b of x is on the left side. We can convert that down here. We drop the first thing that we see, which is the b. So it's drop the b and then swap positions of the x and y. Drop and swap. I think there's some world language classes that use that phrase. So swap the y and the x, it goes b to the y equals x. This works the same going the other direction as long as you have the exponential term first. Log base, and then we drop the b, swap the x and the y. Log base b of x equals y. We get right back to where we started. All right, so first we'll just practice doing this. So I have log base 4 of 16 equals 2. I want to convert this. This is a log form, convert it to exponential. I'm going to drop, so 4, and then I'll swap these 2. 4 to the second equals 16. And we know that that's true. Let's see. Let's do the other method. This should be B-A-E. So base is 5. Exponent is 3. Answer is x. There we go. X equals 5 to the third. By the way, you could even simplify that. We know that that's equal to 125. Now I'm in exponential form. We can do this kind of both ways. So log, let's drop log base 4, and let's swap. Log base 4 of 64 is equal to 3. If I also label this, there's my base, my exponent, and my answer. I can do log, and then it's bay, right? B-A-E. So the base was 4, answer 64, exponent 3. Either way, you should get to the right spot. So pick your favorite one of those methods and go with it. Okay, so 2 special logarithms that we have. The natural logarithm, okay, natural logarithm. Log base e of x. That's called our natural logarithm, anytime your base is e. A lot of times we shorthand this and we just call it ln of x. That stands for natural log. I guess it's like log natural. But ln x, that really means log base e of x, the natural log of x right here. So anytime you see this, I would actually go ahead and change it, especially initially, to log base e of x. Common logarithm is when we have a base of 10. Here the base was e, here the base is 10. So it's really a base of 10. It's often written as just log of x. If we see log of x, we need to know every time that that's really log base 10 of x. Okay, I'm going to do a couple of these from 1 to 6, and then I'll do 1 or 2 from 7, 8, 9. Those are calculator ones that I've circled with the stars on it. So when you're evaluating logs, the first thing you want to do is take your log expression, set it equal to a variable. So I always use x. If there happens to be a variable present in the problem, pick a different variable. So log base 2 of 64 equals x. The way I want to evaluate that is convert it to an exponential. So it would convert to 2 to the x equals 64. Essentially, you're looking for the exponent that you need to apply on x to get to 64. So 2, 4, 8, 16, 32, 64. So I had to do that 6 times. Okay, so 2 to the x, that's going to equal 6. Number 2, log base 8 of 1 equals x. That's log form. Let's convert it to exponential form. Drop the 8, swap the x and the 1. 8 to the x equals 1. Well, there's only one exponent that we can apply to get an output of 1, and that is 0, right? 8 to the 0 would equal 1. So this would equal 0. Let's do number 4 here. So I have log with no base, just says log of 1,000. I set it equal to x. Remember, if there's no base written, we assume it's 10. So I'm in log form. That means I'm looking at BAE, B-A-E. So my base is 10. My answer is 1,000, and my exponent is x. So 10 to the x equals 1,000. Let's see, 3 zeros. That means we have to be 10 to the third. So this would equal 3. Let me do this natural log one, number 6. I'll let you guys try 3 and 5. So natural log, of e to the third. This one has an exponent inside the log, so this is a good one, is equal to x. I'm going to rewrite this. It's really, come on, Larson. Oh my gosh. Log base e of e to the third equals x. So I'm looking at B-A-E. So base exponent. So e to the x equals my answer. E to the third, that should be pretty easy. X is obviously 3, right? So this is going to equal 3. Okay, I will do maybe 7 and 9 real quick here. Okay, so the calculator ones are pretty straightforward. If you're doing log of 200, you have a log button right here. It's right next to the 7. You're just going to hit log of 200. There's no base that's explicitly written, so we assume it's base 10. So let's go 3 decimals, so that's going to be 2.301. Let's do 8. Let's do 8. So log base e, that's really the natural log of 6. That's important because your calculator doesn't have a log base e button. It has a natural log button, ln. It's right next to the 4 here. So same process that we just did. We'll just do ln of 6. That means log base e of 6. And we're going to get 1.792. Okay, you can try those last couple that we didn't get to, and then there's some practice and one more screencast. Thanks, guys.